Space Shuttle Atlantis, a final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
The Sun is the star at the center of the solar system. It is about 5 billion years old and will continue to shine as it does now for another 5 billion years. The Sun is a yellow main sequence star about 1.4 million kilometers in diameter. It consists almost entirely of hydrogen and helium. In the Sun's core, hydrogen is converted into helium by nuclear fusion, releasing energy in the process. The energy travels from the core, through the radiative and convective zones, to the photosphere, visible surface, where it leaves the Sun in the form of heat and light. Solar activity includes flares, sudden discharges through high-energy radiation, which usually lead to sunspots and prominences. The solar cycle or solar magnetic activity cycle is a periodic 11-year change in the Sun's activity measured in terms of variations in the number of observed sunspots on the solar surface. According to NASA, December 2019 marked the beginning of solar cycle 25 and the Sun's activity will once again ramp up until solar maximum, predicted for 2025.
Mercury is the nearest planet to the Sun, orbiting at an average distance of 58 million kilometers. Since it's the closest, it moves faster than any other planet, traveling at an average speed of 48 kilometers per second and completing an orbit in just 88 days. It consists only minute amounts of hydrogen and helium captured from the solar wind plus traces of other gases. To date, only 2 spacecrafts have visited Mercury. The first, Mariner 10, conducted a series of Mercury flybys in 1974. But the spacecraft only saw the lit half of the planet. Another was NASA's Messenger, conducted flybys and then entered Mercury's orbit in March 2013. Now the question is, can life exist in Mercury? The answer is no, because Mercury has extreme surface temperatures, ranging from a maximum of 450 degrees Celsius at daytime to about minus 170 degrees Celsius at night, making it uninhabitable.
Venus is a rocky planet and the second planet from the Sun. Venus spins slowly backward as it orbits the Sun, causing its rotational period to be the longest in the solar system, at about 243 Earth days. Venus is the hottest planet with a maximum surface temperature of about 480 degrees Celsius. The thick cloud layers contain droplets of sulfuric acid and wind speed is up to 360 kilometers per hour. There are 2 highland regions on Venus, Aphrodite Terra and Ishtar Terra.
Finding signs of life on other planets beyond the Earth would be a way of answering the biggest questions that we've had as a species so far. Where do we come from? Are we alone? But of course, these questions are not the exclusive purview of scientists. People have been asking them for as long as there's any record of them being able to ask these questions. What is special about this moment and our role in it as scientists is that for the first time, we're actually able, because we have the tools, to answer these questions.
So a group of scientists led by Jane Greaves from the University of Cardiff were looking for signs, for chemical signs on Venus that shouldn't belong there. And one of such molecules is phosphine. And they, unexpectedly, they actually were able to find a signal that belongs to this molecule. So then we raced to figure out what could be the reason for phosphine on Venus. And this is where our MIT team comes, when we actually looked at all kinds of processes, chemical and physical, that could potentially produce phosphine.
Phosphine is my favorite molecule. It looks more or less like this, a phosphorus atom on top and 3 hydrogens in the base of this pyramid. And phosphine is an extremely difficult molecule to make. It is only spontaneously made in extreme environments, such as what you find in the hellish depths of Jupiter and Saturn. It is otherwise only made either naturally by life on Earth or artificially by humans, as a fumigant, for example.
So the question is why it is actually a staggering discovery, why it is so important. Well, there are a couple of angles that you can actually answer that question with. One, the first, is that phosphine is absolutely unexpected. It cannot be produced on a rocky planet. At least we don't know of any known processes, chemical or physical, that can produce phosphine. Which means either our understanding of the physics and chemistry of the rocky planet is severely incomplete, or there is some chemistry that is so unbelievably weird that it could even be life.
The Earth is the third planet from the Sun. This is the only planet known to support life. About 70% of the Earth's surface is covered by water, which is not found in liquid form in any other planet. The Earth has four main layers: the inner core, outer core, mantle, and crust. Earth has a magnetic field that extends into space as the magnetosphere. Then, why there is life on Earth? This is because the Earth's atmosphere is composed of nitrogen, about 78%, oxygen, about 21%, and other gases are 1%, making it habitable. Also, the Earth's ozone layer protects us from the harmful UV rays from the Sun. Earth's only natural satellite is the Moon.
The Moon is the Earth's only natural satellite, with a diameter of about 3,476 kilometers. The Moon rotates on its axis as it takes to orbit the Earth 27.3 days. The Moon is dry, barren with negligible atmosphere and water. It consists mainly of solid rock. Its core may contain molten rock or iron. Even with the naked eye, we can see that the Moon's surface is made up of two main areas, dark and light. The dark areas are vast flat plains, and light ones are rugged highlands. The missions to the Moon were Apollo 11, launched from Cape Kennedy on July 16, 1969, carrying Commander Neil Armstrong, Command Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin into an initial Earth orbit of 114 by 116 miles.
Okay. At the foot of the ladder, the lamb footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's all... Okay, I'm going to leave that 1 foot up there and both hands down about the 4th rung up. There you go. Okay, now I think I'll do the same. I guess you're about the only person around that doesn't have TV coverage of the scene. That's all right, I don't mind a bit. How is the quality of the TV? Oh, it's beautiful, Mike, it really is. Oh, geez, that's great. Is the lighting halfway decent? Yes.
Did life ever exist on the Moon? Maybe. Have scientists found evidence of life on the Moon? Definitely not. No expedition to the Moon has ever found amino acids or other chemicals that might link up to form living things.
Mars, known as the Red Planet, is the fourth planet from the Sun, and the outermost rocky planet. In the 19th century, astronomers first observed what were thought to be signs of life on Mars. These signs included apparent canal-like lines on the surface and dark patches that were thought to be vegetation. Mars' atmosphere is about 100 times thinner than Earth's, and it is 95% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, and carbon monoxide 0.08%. There are also minor amounts of water, nitrogen oxide, neon, hydrogen, deuterium, oxygen, krypton, xenon. Mars is known as the Red Planet because iron minerals in the Martian soil oxidize or rust, causing the soil and the atmosphere to look red. The northern hemisphere of Mars has many large plains made by solidified volcanic lava, whereas southern hemisphere has many craters and large basin. The Olympus Mons is the largest known volcano in the solar system, 25 kilometers high. Mars has two moons, Phobos and Deimos. NASA is working hard now to discover whether there is life on Mars. Though Mars is more similar to Earth than anywhere else in the solar system, therefore it is a good place to look for life. Without a magnetic field on Mars and with much less layer than on Earth, more harmful space radiation reaches its surface. And it's so cold that most of the water is probably not liquid, rather ice. In 1976, NASA landed robotic spacecraft named Viking 1 and Viking 2 on Mars. One of these worked there nearly 4 years, and the other lasted more than 6 years. The latest explorations to Mars are Curiosity, which landed on August 6, 2012, Maven, which arrived Mars atmosphere on September 21, 2014, InSight, which landed on November 26, 2018. The Mars 2020 Perseverance rover will search for signs of ancient microbial life. The Mars 2020 mission launched on July 30, 2020, and will land on 18 February 2021.
Jupiter is the fifth planet from the Sun. It is the largest and the most massive planet, with a diameter of about 11 times that of the Earth, and a mass of about 2.5 times the combined mass of the 7 other planets. Jupiter's rapid rate of rotation causes the clouds in its atmosphere to form belts and zones that encircle the planet parallel to the equator. Jupiter is composed entirely of hydrogen and helium, with a few traces of other gases comprising a tiny percentage of its air. The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing anticyclone storm. This massive gas giant has a solid core. Jupiter has 63 known Jovian moons. Among them, the largest moons are called Galileans, Europa, Callisto, Io, and Ganymede. The recent explorations to Jupiter were Voyager 1 and 2, launched on September 5, 1977, and August 20, 1977 respectively. Juno was successfully launched on August 5, 2011, which revealed Jupiter as a complex, gigantic, turbulent world. NASA's Hubble Space Telescope has taken an image of Jupiter in ultraviolet, visible, and near-infrared light on August 25, 2020, which gives researchers an entirely new view of the giant planet and offers insights into the altitude and distribution of the planet's haze and particles. According to scientists, Jupiter's atmosphere has no oxygen to breathe. The next problem is scorching temperatures, which make it uninhabitable. But Europa is one of the likeliest places to find life elsewhere in our solar system, as there is evidence of a vast ocean just beneath its icy crust. Saturn is the sixth planet from the Sun. It is a gas giant almost as big as Jupiter, with an equatorial diameter of about 120,500 kilometers. It is thought to consist of a small core of rock and ice surrounded by an inner mantle of metallic hydrogen, a liquid hydrogen. Storms and eddies, seen as red or white ovals, occur in the clouds. Saturn has an extremely thin but wide system of rings. Saturn has more than 60 known moons. The explorations to Saturn, like Pioneer 11, were Voyagers 1 and 2 and used Jupiter's mass in gravity. Assist maneuvers to redirect their trajectories to Saturn in 1980 and 1981 respectively. The Cassini-Huygens spacecraft was launched in 1997. The Cassini mission continued until 2017. Among the significant discoveries were that there are liquid lakes on Titan and geysers of water ice on the south pole of Enceladus, moons of Saturn. Oceans of liquid water, deep beneath icy crust of Theia. Saturn's natural satellites may satisfy the conditions needed for life.
Uranus is the seventh planet from the Sun, and the third largest at diameter 51,000 kilometers. It is thought to consist of a dense mixture of different types of ice and gas around a solid core. Its atmosphere contains methane, giving a planet blue-green hue, and the temperature at the cloud tops is -210 degrees Celsius. Uranus is encircled by main rings which consist of rocks and dust. There are 27 known Uranus moons, among which Miranda has most varied surface. NASA Voyager 2 spacecraft, which made its closest approach to Uranus on the 24th of January 1986, discovered 10 moons, studied the planet's cold atmosphere, and examined its ring system.
From orbit, Uranus gives little away. But plunge below its placid-looking clouds, and you encounter a world that's anything but.
So, let's imagine I was riding an atmospheric probe that's being sent down into the planet Uranus.
Open your spacecraft window here, and you'll quickly feel where the ice giants get their name. In the upper atmosphere, frozen crystals of methane mix with hydrogen and helium.
We might pass some of these towering anvil clouds that we know are there, and as we looked at those, we would look for the lightning, we would listen for the thunder that accompany them.
Free falling here is like descending into a giant green gelato. But the deeper you go, the thicker and hotter the atmosphere. Temperatures heat up to thousands of degrees. Heat left over from when the planet formed.
Eventually, the pressure just builds and the gas becomes basically a fluid or a liquid, and there's no real transition. It's just a continuous increase in pressure and density.
Keep descending, and you'll soon start to boil in a seemingly bottomless sea, more than 2,000 times deeper than the Pacific Ocean. Somewhere down here, a little more than halfway to the planet's center, Uranus's lopsided magnetic field flutters into life.
If you could see down to the surface of the dynamo core where the field is generated, what you might see is parcels of fluid moving about, and they're generally so conductive that those parcels of fluid would drag field lines with them.
Why Uranus's magnetic field is generated here and not in the core, no one really knows. No person or robot has ever been down here.
If we could get even further, we might get to a core, but we're not sure. Isn't that interesting? We aren't sure if Uranus has a core.
Down here, one thing is certain. With a planet load of water and gas on your back, and in temperatures of more than 4,200 degrees Fahrenheit, no life, or robot, will last long.
Neptune is the farthest planet from the Sun, at an average distance of 4,500 million kilometers. Neptune is the smallest of the giant planet and is thought to consist of a small rocky core, surrounded by a mixture of liquids and gases. The great and small dark spots were huge storms. The Scooter was a large area of cirrus cloud. Neptune has 6 tenuous rings and 13 known moons. Triton is the largest Neptunian moon with a temperature of -240 degrees Celsius. Pluto is the larger dwarf planet and it has almost round bodies. It has 3 known moons. It is not considered as planet.
On the road at another billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour.
Dean, there was a huge excitement in the space community. That is because, up until then, the best image we had of the Pluto system was this. Hubble also squinted its lens at Pluto, but it's so small and distant, the best it could see was just a few blobs of color variation. But in 2015, all this changed. That is because, after a 9-year journey, the New Horizons space probe flew by the dwarf planet, giving us a detail and fidelity of Pluto and its moons like we've never seen before.
Science itself a tough subject, no doubt about that. And science tough because science language. What is that language? Mostly mathematics. We all have to some extent mathematics fear. Now this mathematics actually are abstract subject, conceptual subject. Now any sorts of concept that is not easy for any layman or even for any science students also, because any sorts of concept demand high thinking. Now what is the solution? If they want to learn science, how they will learn? An easier method is audio-visual method. What makes audio-visual these things easy? Audio-visual help us to make the abstract into a real one. That means whatever we have to think, audio-visual help us to visualize that. For example, if I ask anybody, think something, that will be tough for him. But if I ask, just see, and what is your opinion, say, it is easier for them. So when they are saying that I am very much comfortable with some audio-visual, say in our daily life we are very enjoy serial, cinema, or etc., something like that. So in that context, if we introduce audiovisual medium for science also, they are bound to enjoy those things. And if they bound to enjoy those things, it implies they will enjoy science. And as they are enjoying science, that will be a type of learning. May not be a proper learning, but that will at least encourage them to learn science. That will be the first footstep. So from the very beginning, that is from the school level, basic level, we should encourage audiovisual medium as the communication of science learning.
When I was studying in my +2, that means 10+2, biology was one of the most difficult subjects for me. And the reason was I could not understand many of the things that was taught in biology. But later, when I listened to some of the BBC documentary about natural selection, about different varieties of animals, I felt biology is so easy. Visualization is very important in understanding the concept of physics and many of the branches of science. If people are taught through some visual explanations, they can understand any science very easily. And today we can see that many students complain they don't understand many concepts in physics and many other branches of science. That is mainly because they are not able to visualize all these images, what they think complicated in their mind. But if we somehow explain most of this concept through diagrams or through some animations, most of the students will say that this is very easy and this is really good.
Audiovisual is a very important tool for communication. It helps us visualize what we normally cannot see. This is true for all subjects, but particularly true for science, and especially so for space science, where we can see only a fraction of what lies beyond. Growing up, it was Carl Sagan's documentary on the cosmos that fascinated me. And though I did not pursue science in later years, it inculcated in me a scientific temper and a curiosity of what lies beyond. It is that curiosity that I tap into even now when I report on subjects to do with science. On Earth, we realize that we are but a speck in the vast universe, a grain of sand in the ocean. Yet, we have, through pursuit of learning, gained some understanding in what lies millions and billions of light years away. And though we haven't yet discovered another planet where life exists, it is beyond doubt that life does exist. Probably not in the form that we know now. Who knows? Those who are now developing projects on science, students in school will someday become astronomers and astrophysicists and will find life in a different world. Thank you so much. This is Shubhro Niyogi, Assistant Resident Editor, The Times of India, Kolkata.